So this unit is two-dimensional motion. We did basic vectors that can point in any direction, and then we've been doing projectiles lately because things flying across the room are both going up and down and sideways. Well, now we come to circular motion. So if you have a circular track, one way of thinking, pretend that's a circle, one way of thinking that this is two-dimensional is we're moving in, like when we're right here, we're moving in both the x direction and the y direction. So this is an example of two-dimensional motion, and that's why I'm grouping it all together this year. So first we need to talk about speed. Uniform circular motion means constant speed. There's no speeding up or slowing down in this particular section. We will deal with that later, but not right now. So you know the equation for speed is distance over time. For this circle, the distance that this object travels around the whole circle is called the circumference. And if we go around the circle just one time, the circumference, we need to do the time for one revolution. So this is usually written, yes, we use v, even though we're talking about speed, because we're talking about the magnitude of the velocity. How fast are you moving? So the circumference is 2 pi r, not pi r squared, that's area. And the time for one revolution is called the period. And we indicate that that's a special time by making a capital T. So there's your speed equation for circular motion. Direction, it's always tangent. The velocity is always tangent to the circle. When this object is at this later point, it's no longer moving that way. It's moving tangent to the circle. It's moving tangent to the circle. It's moving tangent to the circle. Always, always tangent to the circle. Okay, so these are all the velocities. So we have constant speed, but we do not have constant velocity because the direction of the velocity is changing. That means we must have an acceleration. So you remember we did this last year. We are going to define, or we are going to figure out the centripetal acceleration, which measures how fast the direction is changing. So all those equations we call the acceleration equations that we've been doing, those are for only speeding up and slowing down. Changing direction is done by centripetal acceleration. Now this word centripetal, remember, means towards the center. And I pretty much just defined that for you last year. This year I at least want to talk about the direction. So let's go back to hopefully a better circle than the first one I drew. So if this object is here, moving directly to the right, and a tiny bit of time later is moving down and to the right. Now notice that I drew those the same length because these two velocity vectors were moving at the constant speed. So these are the same length and magnitude, but they point in different directions. So if I say this is the original and this is the final, you know that acceleration is defined as change in velocity over the time interval. So for directions, I need to do the final minus initial to get the change. So to draw that, I'm going to redraw the final, trying to copy it as best I can. So this is the final. And if I want to do final minus initial, that is the same as adding the opposite. So my VO points directly to the right. So I'm going to add to this pointing directly to the left, because then I'm adding the opposite direction, so I am subtracting here. And notice my shortcut, my change in velocity points straight down. So if I transfer that back to this circle, there's my change in velocity. It is towards the center. For the magnitude, there's some cool triangle stuff that you length with. These are the same distance, and you have a triangle here, and it's actually similar to this triangle. And if you really want to see that, go look in your textbook, pages 79 and 80. But we're going to skip to the answer because most of you already know it anyway. Centripetal acceleration is the speed squared divided by the radius. It's an interesting geometry derivation to get this, so go look it up, but I'm not going to go over it right now. So the velocity is always tangent. the acceleration is always towards the center. Please, please, please remember that.